All right, ladies and gentlemen, thank you so much for coming. I'm so pleased to see you all here. My name is Ramit Prajapay. I'm the Associate Dean in the Faculty of Engineering and Applied Science here at the university. I'm here to introduce Tom Atkin, whom I've met and known for not very long, a couple of 6 months or thereabouts, but I can't tell you how impressed I am with him. His commitment and his dedication has come across, and he's pushed me to do things that I know I should be doing, and part of that is why we are here today. Tom is going to tell you more, but this is the first of a series of activities we're going to be doing on decarbonizing southern Saskatchewan, and Tom will share the details or some details of what we're doing. I do want to tell you that we are recording this, although we're not having it as a hybrid event. We are recording it, and we will then make it available for others who may not have been able to attend today's session. So to say a few words about Tom. Tom is a professional engineer who has been involved with buildings and sustainability his entire career. He is now retired, which really blows me away because he's so active. He's a retired vice president of Stantec Consulting, where he has held various positions of leadership within building practices. He has over 40 years of experience as a consulting or in the consulting engineering industry with a broad spectrum of building types and the market sector. He has the Governor General's Meritorious Achievement Award, as well as various technical awards, and I'm really not surprised by any of this. He's also a member of the advisory board for the Faculty of Engineering, and we certainly have benefited from his thoughts and ideas in that capacity as well. So I think with that, I will hand it over to Tom and Nanette, who's going to do a part within Tom's presentation. That happened a little bit late, so I wasn't able to adjust the poster. My apologies, Nanette, for that. But with that, I hand it over to Tom.
Sure. So good afternoon. I'm happy that you could attend. I see this as the first step in a journey for the U of R and indeed for our communities as we try to address finally and in an ongoing way the decarbonization of our communities. It's been in the press a lot. We've been talking about it a lot, but indeed many people have been doing stuff already. So what we're trying to do is work on the shoulders of others and also to be more expansive and outreaching with our work. So I thought I'd start with a little bit of background just about the overall effort. And I'm going to speak predominantly on buildings later, but I want to give you a little bit of background with how this series got started and the efforts that the engineering faculty, indeed the broader university is undertaking. So a couple of months ago, through relationships between myself and the other parties, the City of Regina, the university, a few of us got together and we're talking about the then recently adopted sustainability framework for the City of Regina and how we might collaborate to move on and support the city in their efforts. From that, there was a decision to create this kind of ad hoc steering committee at the university. The university, to their credit, has been more than eager to participate in this. And I think it's directly in alignment with the university's strategic plan their vision and their mission statements. And specifically, when the university talks in their, their strategic plan about wanting to have an impact on the world and to empower citizens, this is a direct result of that. So we are trying to be or form a coalition of people beyond the borders of the university that are going to join with everyone in addressing issues. So that's very important. I think since the group is formed, we've embraced the fact that this needs to be done in an inclusive manner. We can't leave anybody behind. And although, the engineering faculties thought of as being a technical organization, and broadly the public thinks of engineers as technical individuals, there is a huge focus in engineering on the impacts on society as a whole. And indeed, if you read any of the publications by APEGs, that's loud and clear. So it's with that in mind that we're undertaking this, and eventually to out of these individual symposiums that we're going to offer, we're hoping to engage with the community, help to draw out unanswered questions, seek a path to answering those questions, and then making the knowledge public so that we can empower all of the different agencies, whether or not they're inside government, in industry, in the general public, to move forward in making change. So as I said before, the genesis really is the city's adoption of the energy and sustainability framework. And they were working on this for quite a number of years, culminated in the framework being presented to council in the spring of last year. Myself and another fellow from industry and a group, kind of an ad hoc group of us in industry that were interested, decided that we would, or were coerced into making a presentation to executive committee and council to speak about the framework and what our thoughts are on the document as a whole and how it might impact things. So, give credit where credit's due. In the mechanical engineering world, one of our big organizations is ASHRAE. It's really the premier technical organization for mechanical engineers in the city. And our local ASHRAE chapter, it's small, but very active and effective. So it was really this group out of our ASHRAE chapter that decided to speak on it. And I think we were received well by the city. We try to address technical matters and also things that we see in our lives as technical people that we need to be worked on by others. I was struck by, I listened to all the speakers, that presentation. Many of them were very passionate about it. And a lot of people really trying to pull in the same direction. So the ultimate success of that framework, though, the city wants to be a net zero city by 2050. But the corporation of the city of Regina only can actually control a small amount of that. They own their own buildings. They can control that. They can control the building codes, etc. But they can't control the broader existing built environment. And so, the success of becoming, or of the ultimate of that ultimate goal, will rest in many other people than beside the city. So we can't rely on the city to be the only entity that's driving the bus. And it's abundantly clear that there's lots of work that has to be done on, you know, an broad array of issues that are going to have to be looked at. Some of them are technical in nature, and some of them are social, some of them are policy centered, and some of them are economic. So we need to ferret our way or guide our way through that, uncover the questions, and start working on them. It is a big puzzle. And one of the things that we pointed out in our presentations and in subsequent work is that we need to do it in the context of our geography, our climate, and our economic and social circumstances. So at the center of our work is the fact that we want to work in between disciplines. So not just within engineering, but within with partners in other areas of the university. And that to make the real positive change, it's the interactions between those different groups that are where you get the good results. So when an economist is working with an engineer, which is working with a policy person, that's where we're going to uncover the path towards getting an impact and making a change. And it was quickly pointed out by everybody in the room at the same time is the city can't do this on their own. I mean, there's no boundaries on climate change. There's no boundaries on CO2 emissions. And so very quickly, the decision was made to stop looking at this through the lens of Regina alone and try to be more expansive to southern Saskatchewan. Okay, so when we were going through our initial meetings, we had a lot of ideas going, but in essence, the initial efforts have been to plan this series of symposia to hear from a broad range of stakeholders and experts, and to share information and our understanding about the current state of affairs in whatever area that they're working. Try to draw out from them questions that need to be answered. Many of our discussions with individual groups, we've come away with more questions than answers. That's a good thing, because we need to pull the questions out, because you can't work on them, the solutions if you don't know the questions. So we also need to figure out where those areas of study should be worked on, because again, just because an agency or a group has a set of questions doesn't mean that they have the skill sets or the scope to address those questions. So in identifying the areas of study and research, we also have to identify the best groups that can work on them. And so we've also learned this will be a good forum just to pull people together and for learning across boundaries and to engage with the broader community. And as Raman has pointed out, there's actually very few members of the faculty of engineering here. That's a good thing, right? We want a broad, expansive engagement with the community, because that's how it's going to ultimately have success. So, this series of symposiums, we have 4 planned and they will all occur in 2023. Currently, we're looking at the first pillar being buildings, second being transportation, the third being industrial, and the fourth being energy production. Now, there's other areas of the economy that need looking at. And I'm sure as we go down our path, we're going to uncover what other pillars we should be looking at. But this is our plan for now. The format that we have selected was to have an introductory seminar, which is this will be, to prime the audience with some background knowledge about the subject matter, and also to perhaps posit some questions to the group, or try to get people thinking about what questions they would want to come to the symposium with. Ultimately, what we're trying to do is not answer all the questions at these symposium, but pull out questions so that we, in our follow-on work, we know what to do and how to engage with the community to do it. We also need to keep in mind there are a lot of impacts on our communities beyond the end goal. We have to answer questions about skills training and labor capacity. That's a really big deal. As I'll get into later on, there are skill gaps likely in the training of individuals, and there are labor capacity issues on all fronts. We need to put our hands around what that is and come up with ideas about solving them. We need to solve issues around social equity. It's one thing for us to work in a particular sector, but for this type of effort, we need to work across all social boundaries and get the entire community raised up with it. And really importantly, we need how to learn to effectively communicate with a clear, common message that we all agree with and that the public can understand. Again, in our own particular areas of expertise, it's easy to communicate, particularly in the vernacular that you're used to. But when you're dealing with a broad range of skill sets in the public, lack of knowledge, not a deep level of knowledge, you need to be able to get your point across. Ram and I were just talking about, our, mentoring of young engineers. And in my world, we used to tell our engineers, you can have the greatest idea in the world, but if you can't get your point across, it's not worth anything. So collectively, we need to develop the language around effective communication and the methods by which to do it to get a common understanding throughout our communities. And we have to remember it is us that are the enablers, right? There's a lot of people that need to be shown the way to do it. And as long as we can keep in mind that we are the enablers of change, that will go a long way towards making progress. And finally, we do need to look across our boundaries. So that's the preamble for the whole symposium series. I think we're going to, based on the results of this seminar and the first symposium, we'll see whether or not we have to adapt for the second one. But that's the general path. And I think one thing for sure is we would like to get feedback from you, not only questions that might come directly out of the content of this seminar, but also on our approach. So in continuous learning, we are always looking to improve our systems and how we're doing processes. So if you have ideas about how we could modify the format, how we can present the material, or otherwise, feel free to let us know how we do. So our first topic area is buildings. And I thought I'd start by trying to put a little bit of context around how buildings fit into the big puzzle of the economy and carbon emissions, and be more specific about how they fit into our provincial context. So as the City of Regina's framework points out quite correctly, buildings are a big contributor to Regina's greenhouse gas emissions. I think I've got the stat right, and Megan from Sask Energy might be able to correct me, but approximately 60% of all emissions in Regina come from natural gas for heating, for building heat. Whether or not you can quibble about whether or not it's 55 or 65 or whatever. It's a significant portion. We are everybody knows we're a heating dominant planet. And because of our great natural gas system, it's the predominant source of heat for industry, for commercial buildings, and for residential buildings. And we're going to talk about those emissions and how we can attack them a little bit later. So the IPCC, the panel on climate change, has said that we need to have aggressive and sustained regulation and reduction in greenhouse gases in order to limit climate change. I don't think I need to belabor that. We're just going to take that as a given, and that people in this room are not going to push back against that. The government of Canada has committed to reducing Canada's greenhouse gas emissions by 40 to 45% below 2005 by 2030, and to reach net zero by 50. So that's a federal commitment. And the provinces have collectively all signed on to meeting a 30% reduction by 2030. Now, I just want to step back and say, every time people talk about emissions reductions as a percentage, there seems to be different dates and data points. So it's very confusing. I think the takeaway is we need to make a big reduction, and we need to make it soon. End of story. So what do we have as current measures in place? Well, first and foremost, we have building codes. And we have our senior code officials for the province in the room right now. And so our building industry is governed in all municipalities in the province by National Building Code and the National Energy Code. And there are others, National Plumbing Code, Fire Code, etc. But the two pertinent ones are the Building Code and the Energy Code. And for context, the province right now is going through their normal and regular process of moving to the next dates of the codes. The codes are produced by the National Research Council, arm of the National Research Council. Federally, they produce these model codes, and each individual province has to adopt the codes. And they make slight modifications in each province, but in large part, they're common. So they govern, the important thing to say is they govern new construction and major renovations. So if you go for a building permit to add a washroom to your house, they will not make you go and change your house to the current code. But if you took a building and added 80% area to it, or a major refit, which was deemed to be significant, and I think significant can mean maybe 50% of the value of the property or so, then that will trigger you having to use the new building codes. But for the vast majority of renovations, it's not required. And the code that the building was built under is grandfathered in. So that's an important piece of information to keep in the back of your mind. So there's other codes. So the Canadian Standards Organization is one that is used heavily, depending on what sector you work in. They can, like I worked a lot of my career in healthcare. There are very specific requirements in CSA codes that have been adopted for healthcare facilities. The same can be said for different types of facilities. And there's an array of these codes that we have to keep track of. The other body is ASHRAE, which I talked about before. It is the American Society of Heating, Refrigeration, and Air Conditioning Engineers, and it is the de facto industry standard in North America for all things mechanical engineering. So even the National Building Code references ASHRAE standards. So ASHRAE as an organization is a huge organization. I think there's, I don't know, 70,000 worldwide members or something like that. They publish standards, they do research, In fact, they fund research here in the province. They have local chapters all over the world, and they develop standards that can be adopted at the local level. So that's another thing to keep in mind. And most important thing is these codes evolve. And over the last 20 years, the codes have becoming more responsive to the requirements of being more energy conscious. So you will see in every evolution of the code, what I call a tightening of the requirements and effectively making newer buildings more energy efficient as we progress. And that's a good thing. And the market, the building market, evolves with it. So everybody in the construction sector and the design sector, architects and engineers, the builders, they're aware of that kind of migration of the codes and accepting of it. And if you get into it, dive into it, you can see the progression over the years of some of the standards. And we know that this is going to change. And I think we are going to be lucky in the next symposium to get a window into codes and standards, a view, and where that might be going, because that's an important piece of the puzzle. So we do know also the cities adopted the framework. And what that means is certainly for the city's own buildings, that's going to guide all their thinking about what they do and in trying to achieve these goals. However, as I talked about before, it is going to be a much broader effort to get the whole community to be 100% renewable by 2050. And that is a very aggressive target for 2030, a 50% reduction. But I will posit that it is entirely achievable. So all these organizations and meetings going on around the world, at COP26, I think there's a statement that they wanted to see by 2030, all new buildings, 100% of new buildings going to net zero carbon in operation, and a 50% reduction in embodied carbon. And I'll talk about embodied carbon a little bit later. But so that's a really aggressive goal. And it implies a 6% reduction or over 10 years per annum. But it's already 2023. So it's actually getting harder. Every year we wait, we're just making the pile harder that we have to address. So here's where you have to get a little bit more, dig down into what the problem actually is in our context. So the International Energy Agency has indicated that the emissions from buildings globally is about 37%. And about a quarter of that 37% is the actual embodied carbon in the buildings. Okay, so that's one frame of reference. Now, when you narrow that down to Canada, NRCan has done its research, and they report that the buildings represent about 18% of carbon CO2 emissions, and that's through both direct and indirect use. But it does not include embodied carbon, so which they say is about an additional 30%. So if you add 30% to 18%, it's roughly 23, 24%. So you can see that Canada is more resource intensive. And so those resource sectors and industry, and we have a sparse population for our area, that then, so as a percentage, buildings don't take about as much of the CO2 pie. Now we come down to Saskatchewan. Saskatchewan is even more sparsely populated. We are more resource intensive. And so the buildings sector only represents about 5 to 7% of greenhouse gas emissions. It varies by which data source you get and who includes what. But it's seemingly saying that buildings aren't much of a problem in the problem. We're still part of the problem. That 5% represents about 5 million tons a year. So we shouldn't be ignoring it. And now I'm going to take a break from that background information on buildings. And we're going to turn this over to Nanette Solomon from SaskPower, because I think that it's very important for all of us to get an understanding of where SaskPower is in the story, because it's impactful for where we might go in the future. And it's going to impact all of the symposium, not just buildings. So Nanette, I'll give it away. Yep, sure.
Like, you say, well, in Regina, right, that all the buildings contribute about 60% of
Yes.
emissions. And in the world scale, it's about 37%.
Yeah.
But in Saskatchewan, it's about 5%. Can you reconcile these numbers?
Yeah, so if you take the geographic boundaries of Regina, we have no mines in the city. We have no forests. We have no farms in the city. No
building, basically.
Yeah. So, I mean, a lot of the emissions can be attributed to, I think if you spoke to the city, a lot of their emissions can be attributed to like the wastewater and water treatment and landfill and then buildings. There are some industries, and whether or not they include, you know, on-site emissions or off-site emissions, is the data for stuff like that is very confusing. So, you know, Evraz is a huge power user. It's not in the city. You know, so where do those emissions? But the emissions are really mostly at a generating station. So yeah, it's very confusing. So give it to next here. Yeah, it's just.
Hello, so I've never spoken to a group that was above me before. It's really interesting view. My name is Nanette Solomon. I'm the manager of supply planning for SaskPower, and this is really my dream job. I went into engineering specifically to be able to have a bit of a hand on the energy transition. And so my group in particular is a team of 10 engineers, and we work with many different departments at SaskPower and externally to work on future supply plans in particular. So I'm going to give you a bit of background where we're at with Saskatchewan's energy transition. Currently, we update our long-term plan every second year. So we're going through that process right now. And we've been going out this year in particular, speaking to the public and trying to get, you know, the public's input as we look to some really major changes. So first, I'll just start with SaskPower's mission, which is to ensure reliable, sustainable, and cost-effective power for our customers and the communities we serve. And we like to tell the story that, you know, Saskatchewan's a bit unique, and SaskPower's a bit unique. We've been serving Saskatchewan since 1929, so we've had a decades-long journey to get to the point where we are right now. We, of course, have a historic reliance on fossil fuels, and that's because the resources in Saskatchewan are really, you know, we have a great coal resource, we have a lot of natural gas, so that's kind of been the backbone of our power system to date. We have one of the largest serviced areas in Canada and one of the lowest customer densities in Canada. So some cool facts, we have more than 545,000 customers, and with transmission throughout the province, you could wrap around the earth almost 4 times. So that's one of the largest transmission and distribution networks in Canada. And I mentioned, you know, we're fossil rich. When you compare us to some of our neighbors like Manitoba, we do have hydro resources, but just not at that same scale that they have. We'll never get to that point where we could be almost 100%, you know, hydropower the same way Manitoba is. So that's somewhat of a challenge for SaskPower. Looking at our current power mix, you can see we do get still 20% of our capacity from hydropower. And that's really the economically available sort of legacy hydro projects that were built many years ago and will last us for a long time into the future. We have our wind capacity now up to 11%. We've more than doubled, actually almost, you know, 2.5 times the amount of capacity from wind in just over about a year and a half. And we have announced, I think, about 1,000 megawatts of new renewables coming in the next few years with more plants there. So you're going to see that starting to shift. We've reduced the amount of conventional coal. Those units are starting to retire. So we're down to about 24% capacity from coal, but a lot of that's being uptaken by natural gas. So combined, we're still around 65% of our capacity from fossil fuels to date. And we have a small other category that has some really cool projects in it. We were the world's first to have carbon capture and storage on a coal-fired power facility. And we're starting to really get into solar. We have a biomass project now online, 8 megawatts up at Meadow Lake with Meadow Lake Tribal Council. And both Regina and Saskatoon have a 1 megawatt landfill gas project, which is kind of interesting. So here's a look at our forecasted emissions performance. The orange line is our historic emissions. So you can see where we were at, and that big dip is really when COVID happened and energy demand took a sudden drop, but quickly ramped up again as people, moved back into the economy with full force. We had a plan. The blue line kind of shows our plan about a year and a half ago, maybe 2 years ago, to get to net zero greenhouse gas emissions by 2050. We're starting to work with that plan. We know that, for example, the federal government is calling for all electric utilities to reach net zero greenhouse gas emissions by 2035. They have new regulations that are yet to be released, but we know they're coming, called the Federal Clean Electricity Regulations. And as I mentioned, we're expecting that to require electric utilities to reach net zero by 2035. The intent with that is to facilitate the rest of Canada reaching net zero greenhouse gas emissions by 2050. So as people look to reduce their emissions, we're expecting more electrification, people moving to electric vehicles, industrial facilities moving maybe to electrification versus, firing something with natural gas. And so energy demand, as far as the electricity system goes, we're expecting that demand to increase significantly. And thus, to get to net zero greenhouse gas emissions, we'll have to have very, very low emissions on our side. Just one point, the gray line there shows that our current target is to reduce our greenhouse gas emissions to 50% below 2005 levels by 2030, and we are well on track to meet that target. Actually, just one more point on that slide. We usually speak here about, how realistic is it for Sask Power to get our emissions down to net zero by 2035? And the answer is it's going to be extremely challenging. You can see that's only 12 years from now. You can also see that our emissions have a large way to go to get very close to zero by that point. And so there's technical, logistical, and financial challenges to meet that goal. The technical challenge is that the technologies that we need to transition from where we are now to technologies that basically don't produce greenhouse gas emissions, they're just not ready yet. There are some that are developing, there's some small scale ones that we're taking advantage of, but the large base capacity of that is still developing. The time to get there is only 12 years. So the amount of infrastructure that we have to change over and build in that time is quite large. So that's challenging. And then of course that will come with a cost. We have already been working extensively to decarbonize our electricity system. I mentioned that we're on track to meet our goal to reduce greenhouse gas emissions by 50% below 2005 levels by 2030. We're also on track to increase our renewable capacity up to 50% by 2030. And we are working to retire our conventional coal units. So we're mandated by the federal government to retire all of our conventional coal units by the end of 2029. And so we're on our path, of course, to do that. And then we're looking at our system as a whole. So that huge distribution and transmission grid that I talked about, that also has to go through a lot of change to make way for a grid modernization so we can facilitate all these new technologies that are coming on. How am I doing for time? Okay, I think I have a couple more minutes.
Yeah.
I don't need to go through this slide too much. It's just showing if we're making decisions today, we need to kind of work with the technologies that are available to us today. So that's the technologies available before 2030. In the interim, we really have not a lot of options to do that transition immediately to net zero. So in the interim, we're really relying significantly on natural gas generation. As we retire those conventional coal plants, we have over 1,400 megawatts of conventional coal to retire and replace. And then we also have energy demand to take care of. So we are adding a significant amount of renewable energy in wind and solar, but as you know, the wind doesn't always blow, the sun doesn't always shine. So the peak demand, you know, that cold winter night, sun's not shining and everybody has their heat cranked. We have to plan the system to make sure that we have enough capacity to meet that highest level of demand. And we just don't know if the wind's going to be there for us at that time. And quite often it's not. So that's where for this transition period, we're sort of transitioning from conventional coal, adding some more natural gas. We are adding some imported energy. So we're increasing our interconnections to our neighbors, which significantly helps with reliability. And both of those two, imports and natural gas, can really help us add those renewables because both of them can react really quickly to the wind and the sun coming up and down. And so we're able to add more of that renewable generation and bring our emissions down even further. If I had more time, I would talk about these other smaller options. I think this group here might be quite interested in these options. Distributed energy resources like net metering on your house, battery energy storage. We're building our first facility in Regina this year. And as that technology develops and the costs come down, we'll get more into that as well. Demand side management. These are some of the customer programs that Dallas Monroe will be coming to speak to you about on April 20th. These are things that can help with energy efficiency and shifting demand from peak times to off-peak times. All of these things are going to help us reduce our emissions in the interim. We're also working on what comes next. So what technologies will be available to us after 2030, and those are really needed to make that final big shift. So that's where we're investing in some innovation right now. We're doing work on carbon capture and storage. I mentioned we were first in the world to build carbon capture and storage on coal. We're looking at that technology now to put it onto these natural gas facilities that we do have to rely on in the interim, and that will help bring the emissions down. We're investing right now in a study on nuclear power on small modular reactors. So a decision on that won't be made till 2029. There's a lot of work to get done to even get to that point to make a decision, but that's potentially a technology that could provide non-greenhouse gas emitting power for us in the future. We're looking at more transmission interconnections to our neighbors, have that reliability and be able to trade with our neighbors. Maybe we're building lots of renewables here. Maybe we can export some of that when they need it, and maybe we can import some when we need it. Adding a lot more renewables, looking at modernizing our power grid, looking at utility scale energy storage. And as I mentioned, Dallas Monroe will be here with Megan Bunny from Sask Energy on April 20th to speak to you more in depth about those customer programs, things that can help with energy efficiency, energy management, some education pieces and technology pieces. So come on April 20th, that's going to be really interesting. And I'll just end my presentation saying, you know, there are, I know I have a message out there that's a bit like, wow, this is challenging, but we are working on it. And we're really interested this year in getting the public's input and trying to kind of work with everyone on a, you know, like a made in Saskatchewan plan for how we can meet this challenge together. So we've got a public engagement process going on right now. If you go to saskpower.com/engage, there's a lot more information about this out there. We have a survey that's closing tomorrow. So if you're really interested in getting your thoughts in right away, go and do that survey today if you can. And even still, there will be other things going on. We have some other power talks coming up. And on that same website, you can put in questions if you want them answered, and lots more on that to come.
Great. Thanks, Nanette. And if you have more questions, hopefully we have a bit of time at the end for more questions. If you think of something in between for Nanette, we can address them then. So now this is the part of the talk where we're just going to talk about buildings. And I thought what we should do is talk about what are the basic principles in the building sector about carbon reduction, things that are kind of immutable, we have to do and incorporate into the solutions. So the first order of business is design. So whether we're designing for new structures, for renovations, for system modifications. We do need the mindset of all individuals in the design sector to shift to a high performance design model. And whether or not they're incentivized or whether or not they're mandated by a code, we need that mind shift change. And there's a good portion of the building sector that wants to produce high performance buildings. There's also a high percentage that just want to build. They don't care. So they're going to build to the minimum code standard and, you know, be done with it. But if we can get first the design community to broadly accept the move to high performance, that will do a lot. I know in the engineering world, Engineers Canada, in some of their requirements for engineers, all engineers, not just in the building sector, is to keep in mind our commitment to sustainability and resiliency, and it is, you know, ethically part of what we're supposed to do. We just need to turn that into practice. So, and in the buildings world, one of the big things is numerical modeling, energy modeling. And so you see a lot of these cool renderings that buildings are produced for buildings. Most of them are geometric models, and they're really to demonstrate how the building fits together. But on the actual engineering side, there's a whole bunch of modeling techniques that are used by mechanical engineers, structural engineers, electrical engineers, that actually model how the results, whether or not they're in forces or temperatures or energy use, and how they're used. You know, my focus has always been on energy. And so energy modeling has now become an extremely mature tool in the industry. I started my career in the early 1980s. We were already modeling then, albeit with mainframes where we had to send the material away to Toronto and wait for 2 weeks for them to send us a package of papers back. But now all of the computing power is available on your desktop, and it's extremely powerful. Oops. The second one is life cycle assessments. So I alluded before, or I mentioned before, that a good portion of the energy in buildings is consumed or is identified as embodied carbon. That's really, what is the carbon required to make the products, extract the materials, make the products, build the buildings, and then get rid of the building at life cycle. And it's not insignificant. And your choice on those materials can be heavily influence what the embodied carbon is for it. And so that's something that's been a rapidly evolving part of our business, say over the last 10 or 15 years. It's only in the last few years that we've had good tools and good benchmarks for imparting embodied carbon in products. It's not universally adopted, but I think that we're going to see a more aggressive move in the marketplace to requiring embodied carbon to be put on like a nameplate or product listings for comparison, and then actually be incorporated into the design. So a little graphic about where the carbon is actually used. Most people think, when they think of carbon for anything, it's the operational carbon. So you can see from the graphic, that's only a very small little part. It's a long part because the building could potentially, you know, have a lifespan of 25 or 50 or 75 years. So you're going to build something and it's going to generate carbon for a long time. But we, you know, don't want to lose sight of the embodied carbon and the decisions that we make in both design and procurement, how we affect that. Next principle we have to keep in mind is, how is the energy used in the building, and it's operational carbon. So the basic principle of all carbon reduction in the building sector is, number one, is you have to decrease energy use. So Nanette mentioned demand side programs. That's the same word for increased energy efficiency. Reducing the amount of energy you consume so that the kilowatt of power that you don't consume, you get 100% carbon reduction on that 1 kilowatt you reduce. So if you reduce your energy use in your building by 50%, you automatically, without doing anything else, reduce your carbon by 50%. So that's why demand side management for energy efficiency is so important. The second part of it is, as we potentially move to electrification, as Nanette talked about, if we just simply move to electrification without increasing the energy efficiency or decreasing demand, we are going to have too high an impact on the electrical grid. So this is one of those things where you're actually benefiting by doing something at the use level, say the house, the small building or whatever. You're actually positively impacting another sector by reducing, every kilowatt that you don't use, SaskPower doesn't have to build and distribute and transmit. So, and one of the important things to keep in mind is we do need to keep flexibility in this interim period high. And I've talked about this before. We have to think about decarbonization kind of going hand in hand with the electric grid's modification, their decarbonization and their increase in transmission, generation, and distribution capacity. And time is an important variable. Nanette had a slide up and she shows a graph over time. So time matters. When you do something, it's almost as important as what you do and the sequence in which you do them. So I've mentioned embodied carbon before. The first step is to try to reuse our existing building stock. So instead of taking a building that doesn't meet its current purpose and simply demolishing it and building something else, we should be thinking of adaptive reuse. It's not that adaptive reuse hasn't been done in the past, but if we can continue on that effort and keep expanding it, again, we're impacting the embodied carbon in the structure and the materials included in that building. And again, we need to inform ourselves on life cycle assessments, because there will be times when demolition actually is the right approach. But it's not to say that we'll never demolish a building again, but we need to be able to have the data that supports whether or not something should be reused or not. So here I'm back to retrofitting buildings and energy efficiency. If you consider that the building stock in the province, some date back to the 1920s. There's houses in Regina that date to the 1920s. You think of the heavy build-out periods in the city. There's a huge number of buildings that were built in the 1950s and 60s. And then there's some gaps in time when there wasn't so much construction, but there's a huge amount of the building stock that's old and predates modern codes where energy efficiency finally was incorporated into those codes. So what does that mean for us? We need to address the loads in those buildings. So first and foremost, again, we're a heating dominant climate, and because there's so much energy used by space heating and water heating, but space heating predominantly, envelope upgrades are the gift that keeps on giving. Once you've done the envelope upgrade, there's little to do to maintain it, and it's going to reduce your load and your consumption for the rest of the life of that building. So as a mechanical engineer, I do stuff about putting heat in, but my main message is to people, don't make me put it in. Or if I'm going to put something in, let me make it the smallest thing that I can do. So the for the vast majority of the existing building stock, envelope upgrades are the #1 path to decarbonization. Again, if you don't need that BTU of heat going into the house, then you're not going to consume it through your furnace, and thus the emissions. Second part of that is smaller, is capturing and recovering waste heat. So you can think of the exhaust streams from the building, whether or not it's your house and a heat recovery ventilator, or much larger facilities, exhaust systems for hospitals or university buildings. You want to recover that waste heat and use it to preheat the ventilation that does need to go into the building. You need to fully adopt LED lighting. LED lighting pays for itself today. If you change out a fixture and put an LED light in, you're saving money like right now, and the payback for an owner is somewhere less than 2 years. Like it's a no-brainer. You should absolutely be doing it right away. Again, reduce the electrical load, and our crew doesn't have to plan and to design that capacity. So that's something, but there's also appliances and plug loads that need to be paid attention to as well. Then you get into the kind of the more sophisticated things. There's smart building controls that can be done. They've been widely used for decades in large commercial and institutional buildings. And in the last 15 or 20 years, they've become more cost effective at the residential level. And of course, one that's always forgotten about is building maintenance. So if you don't keep things up, particularly the mechanical things and electrical things, you're going to use more energy. So I thought I'd give a little example. This used to be my house, and I had plans for it, so it was easy for me to look at. So it was built in 1951, and when Joanne and I moved into the house, nothing had been done to that house, like zero, in the 30 years or 35 years that it had been there. Subsequently, we did a lot of upgrades, but if you took that example, because there are other houses in the area to this day have had nothing done to them, I thought, oh, what if we applied today's codes or the measures that are included in the NRCan Greener Homes Grant? What would that do? So I did some hand math, and oh, it's pretty good. Like we cut the use by, I think my hand math was 55%. So it got me thinking about things. And as we were going through our little journey with our ASHRAE colleagues, we decided that, since the housing market needs some inputs as to what is beneficial, and there's none of the commercial engineers really have any impact on the residential market. So we thought, why don't we as a group just look at a couple of sample homes and do some modeling? And so roundtable our ASHRAE community, and we came up with this plan. McPherson Engineering has been graciously doing the modeling work, and we're partway through the process, but it's exactly what we thought. I know my hand math wasn't too far off, but we're using modeling techniques. And by taking a 1980 building, like mine was a 1950 building, but by taking a 1980 building and applying the Greener Homes Grant, you can reduce the energy demand for that building by 60%. So that's, and if you look at the greenhouse gas emissions reduction, it's 57%, and utility costs by 51%. Like, we're not through the process, and we haven't done all of the QA/QC on it, but it points towards a market improvement on the demand side. And that doesn't include HVAC upgrades. That's just the envelope. So if you look at HVAC upgrades and lighting upgrades, that number is going to rise to more like 75% reduction. So that's, an important piece of information. I have to point out that houses, small commercial buildings, multi-unit residential, they're fairly easy to assess, and the number and breadth of energy savings measures are not huge. I have to say that there's another aspect to in the commercial building market and in the institutional and industrial market where there are lots of process needs that change the array of measures, and they won't necessarily have the same impact. So if you look at a very large building that has a relatively small surface area to the building area, you're going to see highly varying numbers. But the basic principle around it remains the same. So the next principle you need to look at is adopting clean heating. So clean heating can mean quite a few things. First off, it can just mean increase the efficiency of the natural gas burning device. Take your old furnace that's 80% efficient and put in a condensing furnace or condensing boiler that's 95% efficient. So you get the efficiency improvement right away. You can adopt heat pumps, and there are many different types of heat pumps and heat pump systems. And in the symposium in a couple of weeks, I am going to give a little primer on heat pumps because it is very confusing for the public. And there are so many options out there that it's very difficult to get the message clear to the public what the right approach is. There are also utility implications for heat pumps. And so it just will clear the air a little bit on that. There's a consideration for solar thermal in Saskatchewan. I don't think solar thermal gets enough traction here, but we did look at solar thermal for a project 7 or 8 years ago, and it actually had a better payback than photovoltaic. So it's very simple technology. Just think of a black panel with tubes in it and a glass, and you stick methanol or glycol or something through it. It's simple, and it's been around for decades. You can consider deep geothermal, and I know that there is some work going on in the city, and perhaps something going on at the university. I don't know that that's actually being considered for sure, but deep geothermal is a resource in southern Saskatchewan. Certainly it's a better resource in the southeast, because you can see by this picture in the middle, there is a temperature variance in the water, the groundwater, as it moves from southeast to northwest. And we're in an okay spot, but we're not like in the optimal spot, but we can still make it work. So Nat mentioned load shifting, so thermal storage and or load shifting can be part of the considerations. And of course, the primary energy source, the electrical grid, and what that has to do. So if I just talk quickly about the new home market. So you can build a net zero home today. Like it's possible. We have the technologies in place. We have the wall assemblies, the envelopes, the heat recovery, everything's there to build it today. You have to be motivated to do it because there is some cost to it, but it is actually possible. And we do need to move that new home market towards net zero quickly, just as the message in COP26 had pointed out. That is a part of the puzzle. However, we only build about 2% of the building area every year, 1 to 2%. So that in itself is not going to solve the problem. And we need to keep in mind that a lot of these changes, if there's a major life cycle event, like a change of use of the building, that is the appropriate time to implement a lot of these measures because you can do it more cost effectively. And again, get back to keeping in mind that best practices in maintenance and operation There's lots of publications about what that can mean in terms of energy savings. The kind of accepted norm is somewhere between 10 and 15% energy savings if you keep your building maintained properly and the controls are operated optimally. Keep your thermostat set points where they should be. You know, ASHRAE right now has a little program where they're trying to promote, you know, just simply reducing your thermostat set point by 1 degree in the winter and raising it by 1 degree in the summer. It makes a difference. I mean, you're just going to heat less and cool less. And now I'd like to turn our thoughts to what are the problems? Like, what are the challenges that we need to address? First off is the rate of change. Like, we need to make change fast. And there's lots of things that have to be addressed in that. But if we're going to move to 2050 to being net zero or no emissions or all from 100% renewals, that's a tremendous amount of work in a short period of time. And the interim target, 2030, is even more aggressive. It's only 7 years. If any of you that have been involved in a large project, it can take 7 years to develop a project. You know, you'd be a project like a hospital project, a greenfield hospital project you're starting work on today will not do its first surgery for 5 to 7 years. I mean, it's a long time. There's a huge window of time that it takes to make these changes. Cost, it's a big thing. Funding. It's estimated in Canada that make the entire building stock retrofitted by 2050 would need 20 to 23 or $32 billion per year. I mean, we have massive building stock that needs to be addressed. This is a graph from the City of Regina's Energy and Sustainability Framework, and it estimates that the city will require $11 billion between now and 2050 to get to 100% renewable city. It's a huge amount of money. How are we going to pay for it? And especially when there's nothing mandatory that makes most of the changes that are required either unfunded or there's no motivation to do it. We need to create the incentives to make that change. The next area is people and materials. We already have a significant labor shortage in the trades, and we're going to see that get worse with the number of retirements that are coming up in the labor market. We also see supply chain issues, and that we do not play in a market that produces everything. We rely on many materials that are either constructed or sourced from the US or overseas, and they are all going through the same effort at the same time. So supply chain issues and labor issues are going to be a significant obstacle that needs area that needs to be addressed. We also need to think about training. Like, do we have all the skills in the trades that are there already? And so that needs to be looked at through our work. And we need to think about affordability. There's a lot of people that can't afford to do this, and in the residential market. We also have to think of other markets, like the rental market, where the landlord, he has to be motivated to make these changes. So that's an area for a lot of discussion. And finally, or maybe not finally, our cold climate. Our cold climate does present real challenges, real technical challenges. And I was talking to some people beforehand about the fact, we're heating dominant. And if you're using anything like a deep or ground source heat pumps where you're relying on the earth as a battery, really, to store heat energy, you take out more than you put in the summer. So how do you address that imbalance? That's a technical issue that needs to be resolved. Air source heat pumps. Everybody talks about heat pumps being great, but we have to recognize there's not a heat pump on the market right now that operates below -25 C. they shut off because they physically don't work. They also have a performance tail off a few degrees above 11, minus 20, their performance tends to, that's the best one on the market. There's a lot that don't even do that. So we need to address that and find solutions that are very location specific. And for commercial and real estate owners, there's a degree of uncertainty on their return on investment. And that can't be ignored. You know, again, motivation is going to be all different for whatever sector of the building market you're playing in, but we do need to find that sweet spot. And of course, the impact on Sask power. I can't overstate that fact because the world is moving towards electrification, and it needs to be done carefully and in lockstep with what Sask Energy and Sask Power are doing. We can't ignore it. There are limitations in the electrical system all over the place. They can be from the power pole in your back alley all the way to the generating station. There are limitations. And so we need to accept it. We need to, again, find the questions that need to be answered to help Sask Power in their planning. And that goes right through their system. Sask Energy needs to know what's going to happen with utility use. How is gas demand going to go up and down with whatever solutions we have? So this chart that's up there, this is from a 2019 study by the Canadian Gas Association on the impact of heat pumps on the electrical system in Canada. And so for reference sake, the top line, the dashed line, low EE sensitivity, that's saying what will happen to electrical demand if you shifted over a certain percentage, not 100%, I think it was 75% of the existing building heating loads to heat pumps as they are now. The energy efficiency levels, so no improvements in the energy efficiency or operation of a heat pump. So you can see that's a dramatic rise. It rises from like under 100 gigawatts to a peak of like about 300, shy of 350. That's a huge increase. Right now in the marketplace, NREL, National Renewable Energy Labs in the US, which is part of the Department of Energy, and NRCan have a cold climate heat pump studies going on, which is like a all-out effort to improve heat pumps. If those scenarios come true, then you have the curves scenario 1 to 3 and 4. So those accept the fact that heat pumps will improve. And there's all the preliminary indications is that those efficiencies are going to be found and the marketplace will be able to produce them. The difference is in scenarios 1 to 3, they're trying to use heat pumps for 100% of the peak load. So that dark night that Nanette talked about in the middle of winter, when you've got your thermostat turned up, the heat pump does everything. And if it doesn't do everything, it's electrical resistance heat that makes up the difference. So you've taken the gas pipe out of your house and it's only electricity that feeds the house. That's what scenario 1 to 3 does. Scenario 4 is a hybrid approach. What if you said, I'm going to put a heat pump in, but I'm going to leave my gas furnace there. So when it gets to minus 25, the gas furnace turns on. Okay, so it's a peaking load. So it's taking over when the heat pump can't do it, and putting that load on the gas system as opposed to the power system. That's scenario 4, and that is a plausible solution in a heating dominant climate. You know, we're not Southern Ontario where a heat pump can do everything. You know, we will need supplemental heat. I can't see them developing a heat pump at minus 40. There's thermodynamic reasons for it. And it's like you're trying to make the problem way too hard. So this hybrid approach is likely the approach that is going to have to take. And it makes a huge difference on the power network. It's a good study. Actually, you should look it up. If you just Googled 2019 Canadian Gas Association energy study, you'd be able to find it. So if not, I'll give to Raman what the link is and can share it somehow. So this is what I was alluding to, why the difference, there is a difference, and what leads to some research that needs to happen. So this is a curve of time and temperature for, it's an average curve for Canada. So you can see that there's many hours. So the vertical bars are numbers or percentage of time in a year that we occupy. And you can see the temperature distribution along the bottom. So you can see that, yeah, it gets really cold here, but there's not that many hours. And we all know that anecdotally. Yeah, it's cold here, but it's not for that very long. And, you know, realistically, we have a lot of hours that are only just cool. We're not as cold. Yeah, you can take what you think of that. But this is a curve for Canada. So whatever studies we're doing, if we use this data, it wouldn't be right for Saskatchewan. And I can tell you the curve for Saskatchewan shifts to the left. And it doesn't shift a lot to the left, but it shifts to the left. So yeah, where they might say that 1.4% of heat demand is below -25, that's not quite the case. It's more like about 7% for Saskatchewan, something like that. But it's, it's still saying that it's a small amount of time when we're in that low. So, if we're studying the impacts of heat pump implementation in Saskatchewan, we need to use the rate data, and the data is already there, but there's not studies that have been done that have been, Saskatchewan specific. And we need to form partnerships. So we need to look, and those partnerships can be in finding funding sources, incentives, how we fund incentives, technical associations that are going to work together, working across groups like the Home Builders Association or the Saskatchewan Construction Association. It can be looking for partnerships. We have a great resource in waste heat in the refinery. The refinery rejects a huge amount of heat. Lots of technical issues with how you could capture that heat, but it seems to me that's something that could be studied if we got the right circumstances where you can have a waste heat emitter and a user. If they're in the right geographic proximity to one another, we should think of that as a resource to capture. So what are the other partnerships that we need to form? Which comes to our symposium. So this is our lineup for the symposium, which will be in a couple of weeks. First and foremost, we're going to have Greg Kuntz from the City of Regina speak. Greg's the director for sustainability at the city, and he'll be giving his perspective, the city's perspective, and some of the opportunities and challenges that come for the city, and the big questions that they need addressed. We're going to have Megan Bunny and Dallas Monroe, Megan from Sask Energy and Dallas from Sask Power, talking about the demand side management and programs and other aspects that affect the utilities, because we can't do this without fully accepting the impact that we will have on the utilities. We'll have building standards. Ty Tweed from Building Standards is going to talk about the codes, which I think everybody needs to understand, because there's a lot of changes happening in the codes, not just in the near term, but in the medium term. So the community needs to get their head around where codes are going nationally and provincially. And so, because it takes time for the rest of the marketplace to adapt to that. We're going to have Andy Arunalas from the faculty, engineering faculty, and myself. We're going to speak on a couple of technical matters, and hope we don't bore you on that. And we're going to have Stu Niebergall from the Home Builders Association to give some perspective on the residential construction side. And on the policy side, we're going to have a couple of individuals, Alyssa Nippard and Kevin Lockhart from Efficiency Canada, that are kind of talk about policy matters. So we think that we've got a good cross section of players in the marketplace. We're not, again, as I talked before, we're not just trying to be technical. We're trying to pull out questions from every aspect of the community and then formulate plans on how we're going to work on them. So that wraps up my speech. And I guess I would open it up for questions.
Okay, I agree with you, the change is too slow.
Yeah.
I think before you started your presentation, we talked about this so-called energy transition.
Yes.
Doesn't sound like to be a transition because like we have been talking about this 10, 15 years.
Yes.
And we have put billions of dollars in here, but still the amount of fossil fuels that we use is still pretty high percentage, right?
Yes.
So it doesn't sound like a transition. Now my question is, when we talk about embodied carbon there too.
Yes.
When we look at all the other technologies, there's a lot of embodied carbons in those kind of technology.
That's right.
And the mining part or whatever.
Yeah.
So eventually, I'm just wondering whether the SaskPower did that study, life cycle analysis study. So basically, those kind of technology may even less environmentally favorable compared to burning fossil fuels if you can do carbon capture. You see what I'm saying? Because like people talk about EV, right? Electrical vehicle that we don't really have sufficient lithium for making all these batteries. Basically. And dividing a mine will take 15 years, 10, 15 years. Those projects would be 7, 8 years. And with all this, and I thought about like, are we really doing this transition? I mean, does it make sense to do it like given the embodied carbons for all the other technology pretty high actually?
Well, thus my emphasis on energy management, reducing loads. That, I mean, that's a rule in engineering. You're trying to make whatever process you're trying to do as efficient as possible, right? You know, within economic or other technical constraints. And so, but I get back to the BTU you don't consume or the kilowatt you don't consume. You don't have to produce, you don't have to transmit, you don't have to do anything. Like if I need my car parked in the driveway, I'm not burning any gasoline, right? So it's about energy avoidance in the first instance, and then moving towards what are some of the other active measures. Now you've minimized the amount of energy you need. How do you produce it in the most effective manner and responsive to the needs? So
yeah, I agree.
There's a reason in the waste in the waste management market. What's the rules? Reduce, reuse, recycle. We've heard that word for decades, right? There's a reason they're in that order, right? Reduce first, you know, and then you don't have to worry about reusing or recycling. So it's the same in the other markets. Is reduce the amount of energy you need, then you don't have to produce it in the first place and look for active ways to reclaim it and so on. The other heroic measures.
Thank you very much for the talk.
Go ahead.
A question about, you talked a lot about the regulation and the transition and so on. The message to me was, we're not going to make 2030 line folks ask, but maybe 2050. But you didn't talk about the marketplace. And I'll use this as an example. When I buy a fridge, it's got that sticker on there that says, here's where it is on the scheme of the power, the long-term cost of operating that fridge. If that was required of rental properties, real estate, then the consumer would know what they were getting into. And if they wanted to boost the value of their property, you're going to sell your house. Well, if I invest 5,000, I'm going to make 15 because my rating on that scale will go down. And that doesn't require anybody to admit that climate change exists. This is simply an educational thing that you're providing to the consumer. And if I buy a house, I have to have an inspection report. So if it's included in the inspection report, I've got that information. If I choose to do nothing with it, I've done nothing with it. But I suspect a lot of people will be motivated to say, I can increase the value of my house, A, or B, I can reduce the operating, I can purchase a house or an apartment or condo or whatever that has a reduced operating cost. Or if I go to rent a retail space, I want to rent the space where the operating cost is not going to be a major component of my business plan. And that will motivate the marketplace for real estate industry and the home builders, because the amount of renovations, and then if there are things the federal government provides in terms of funding, and I know Sask Energy does, those kinds of things would facilitate that transition more rapidly than waiting for the building code to change over the next 10 or 20 years. One could argue whether the building code should change sooner rather than later, but it's not.
What you're talking about is referred to as building labeling. I mean, it's the same thing as food labeling,
Sure.
right? And building labeling exists in different marketplaces and is mandatory in certain marketplaces.
Well, if I live in Calgary, and I can see the energy demand of my house or my retail space up and down the block across both those cities. I can do that.
Yeah.
Can't do it here.
Sounds like a program that should be looked at. Sounds like one of the questions that should be addressed.
I think this.
I can quasi answer that question before. I'm speaking from the homeless. Okay, sorry. I've got a little bit of knowledge of this. My presentation on that day is going to be focused a little bit more on the consumer side and how to do that in this areas. But when you think of labeling, Tom, you're very right. Labeling's been actually around for a long time. You can get your Energize label for your energy auditors or any particular home as an example that you want, but they're not mandatory. So I know for us as a local association nationally, we have advocated for probably a good decade of all homes in Canada that very particular point. But where it gets complicated around these things, because everybody's a stakeholder in every area. And so if you are a homeowner and not planning on doing this type of labeling, the last thing you want is mandatory labeling to point out those differences. You may have an organization like the Realtors Association who adamantly fought against labeling. So it's complicated in a democracy, but they move these things forward solely on a regulatory basis. And it's really about moving the consumer often in these areas. And none of it argue with that point, and I appreciate the point. But somebody somewhere decided that I can't have aluminum wiring in my house anymore. Somewhere somebody decided that my plumbing has to be a certain standard. Somewhere somebody decided. So the mandatory, I mean, either climate change is urgent or it's not. And this is an example where nobody has to get heavy handed, other than if you're buying a house, selling a house, renovating renting a retail space. That simply comes with the inspection. I mean, they tell me if I've got broken arging on the side of my basement.
Right.
But you can't tell me whether my house has a poor or a good rating for energy consumption.
Right.
I mean, there's a non sequitur there.
You're not going to get any argument from me on that.
No, and it's easy to do. Yeah, it's not easy. I don't expect them to do anything with the information, but if they don't have, means I talk to my neighbors and none of them know about the federal grant.
Yeah.
Right. That's 40 grand. And nobody knows.
You're talking about the public. I talk to different individuals in industry. Not everybody knows. Like there is a huge education effort that needs to go on, like a massive education effort needs to go on to make this happen.
So my name is Orly McPherson. Thank you, Tom. This was really impressive. And I'm really impressed with the university for doing this. This is exactly the pivotal moment. A lot of times we think climate change is too hard. The first thing that needs to be done is getting together, getting a round table and bringing the best and the brightest to the table. Tom, I was really impressed with your comments about communication and collaboration. And it goes back, it segues to what's being talked about up here, is that the university, it's all about public trust. In order for our community to shift gears, we need public trust. The university pulls that golden coin. The public loves to hear what the university has to say. As a neighbor, if I tell my neighbor, hey, you're glad, they're not gonna listen to me. But if the university comes out, we really do need a communication strategy that builds community confidence. And I think Saskatchewan, because of our demographics, is one of the few places that we can do this because we know each other. And what do you think?
I guess one of the initiators for the efforts of all of this, for the symposium, for forming the working group, was to help involve the university or get the university out in front of problems, facing problems that the community has, and help to be part of the solution in addressing those concerns. So out of these symposium, we are thinking that there's going to be studies that need to be initiated. There be pilot projects that probably there's questions that people have, whether or not, you know, Sask Power or Sask Energy have questions that need to be addressed. Others, and then, you know, home builders in developing programs, the city, whatever, you know, there's the university is positioned to help be part of that. And whether or not they have to bring in others, not in the university right now, or other academic partners that might be working in the space throughout Canada, which there's lots. I mean, there's tremendous number of connections, but you know, we need to pull the questions out of the community first before we can answer them. So the symposium is really like a big cry out, like, what are the questions we need answered, and we'll work on them. Because as engineers, you know, if you present us a problem, we're going to find a solution for it, right? That's what we're trained to do. Apply science to fix a problem. We need to know what the problems are. And if they're policy related, you know, we can help inform policy. If a demand side management program says, you know, what are we going to need to get envelope upgrades pushed higher up on the agenda? And the university can do a study that says, you know, the Greener Homes Grant pays you a total of about $20,000. I'm picking the number out of the air. $20,000 to upgrade your envelope. It's not nearly a big enough incentive. So what does that incentive need to be? And it depends on the marketplace. So, you know, get economists involved, other policy people to say, you know, in the rental housing market, you're going to need to incent them with X to make them do that. Or you're going to need to, you know, force a labeling program, or, you know, whatever the mixture of solutions are, because there's not one solution for this. It's going to have to be developing an array of solutions, a toolkit that can be applied to the problem, because there are no universal solutions for any of this. And whether or not we're talking about buildings today, but we're going to be talking about transportation in May and June, how do we have to apply those same principles of pulling out questions and thought and research into addressing those issues. So.
All right, I think it's a little after 3, so I think we should maybe finish wrap this up. But let me first ask you to join me in thanking Tom and
if there's one last takeaway, bring a buddy to the next or two.
The next event, we would like you to register with an email so that we can contact you. So go to the events page on the U of R Faculty of Engineering site where you saw the information about this, and please register, bring a buddy. If we overflow this room, I'm going to book the main auditorium, so we'll just move there. Okay. So thank you so much. Yeah, no, I love this.
Yeah.